Welcome back. Today we're going to be continuing our work with right triangles, specifically looking for angles. We have been looking for sides using our trig functions, and today we're going to be looking at trying to find out what our angles are given two of our sides. So if you have your notes, go ahead and grab those out. If you don't have your notes, you can grab your journal out. That works just as well. Like we've been using in class, if you will, in your computer, if you'll pull up Desmos Scientific Calculator, that's probably the best calculator to use here, and it has your trig functions really easily accessible, just like this. So we've been using sine, cosine, and tangent. Today we're going to talk a little bit about what these values are. This is called inverse sine, inverse cosine, and inverse tangent. So I'm just going to write those down for us here. So sine to the -1 power, that's the same as me saying inverse sine. So that's how you would say that, inverse sine, right? And then cosine, oh, my marker's not working very well. Cosine to the -1 power is the same as me saying inverse cosine. So just keep that in mind. When I say inverse of a function, that's what that means. It means that function to the -1 power. All right, let's go ahead and get started. Let's look at our notes here. If I want to find the angle value of a right triangle, remember we're always using right triangles in trig functions. We're going to use the inverse sine, inverse cosine, or inverse tangent. We're going to go about it the same way. So here's our key point here is we're always going to start with the angle. So write that down on your paper. Always start at the angle. Even if you don't know the angle, that's where you're going to start. So always start at the angle, okay? And then you're going to find your ratio. So same thing, the ratios are the same, right? Inverse sine is still opposite over hypotenuse. Remember, it's so. Inverse cosine is still adjacent over hypotenuse. It's ca. And inverse tangent is still toa. It's opposite over adjacent. So remember our so, ca, toa. We're still following that ratio as we go. All right, so these down here, the example number 1, we're just plugging those into our calculator. So we're just going to practice using our inverse sine, cosine, and tangent. So if I plug in inverse sine of 0.8, we should get 53.1. So think we're looking for an angle. So if you get something between 0 and 360 or 0 and 90, really, that's what you want. You want a number between 0 and 90. If you get something that's not between 0 and 90, you want to check your calculator functions again, okay? So here we go. It is 50 rounded to the nearest degree, 53 degrees. So let's look at this cosine of 0.19, or inverse cosine of 0.19 is 79. So that's a good angle measure too. Remember, we want something, because we're dealing with right triangles, we want something that's less than 90 degrees, greater than 0, right? So think about that. You want your angle to be greater than 0 and less than 90 degrees, okay? All right, go ahead and do the next ones on your own. Inverse tangent, we're just plugging in our calculator. Inverse tangent of 3.4. Just keep in mind I'm toggling between the main and the function. The function is where your inverse is. And I get 73.6. I'm rounding it to the nearest degree, so that 6 is going to bump my 3 up to a 4. All right, let's actually look at this with some triangles here. So if I have a right triangle, man, my markers are just not working out for me today. If I have a right triangle and I'm looking for the angle value here, x degrees, and this is 3, and this is 1, we're going to follow the same steps that we have been following to figure out what ratios we're going to be finding. So I'm always starting at my angle, right? So you can always use your colors, right? What is 1 from X? Well, I have to go all the way across my triangle. It's my across the street neighbor, so it's opposite, right? And then what is 3 in relation to 1? So if I highlight that 3, I know it shares a side. It shares the side angle, just like if you share a fence with your next door neighbor, it's adjacent. So I'm going to look, what am I using? So, ka, or toa. I have opposite and adjacent. I'm going to use tangent. So we're going to say the same thing. Tangent of x, always of the angle, equals opposite value 1 divided by adjacent value 3. Okay, so I'm going to prove to you mathematically why we're using the inverse of this. Thinking about solving for x, right? Let's separate these. If I separated this, this would be like dividing by tangent, right? If I want to divide by tangent, if I want to divide by tangent, that's the same as me multiplying, and you'll learn this in algebra 2, by the, think about this as tangent raised to the 1 power, but it's in the denominator. So if I wanted to move it to the numerator, I would have to make that exponent negative, okay? So it's tangent, the inverse of tangent times 1/3, okay? So let's plug that in our calculator, see what we get. So we get inverse tangent of 1 divided by 3. 18.4. So my x value equals, and it says to the nearest degree, so that 4 is smaller than 5, so I'm going to keep it at 18 degrees. You don't have to show your work like this. If you know that you're looking for the angle, you can just write this, okay? So let's write our work down on our paper here, and we'll continue. So starting from the angle, I'm just going to review. I had to go across the triangle to get to my 1, so that's the opposite value, right? My 3 was right next door, it's the adjacent value. So remember, we're still following our steps. Label, write your equation, solve your equation, and then plug back in. So in this case, I labeled, right, opposite and adjacent. Now we're going to write our equation. We know that we're using tangent, so tangent of the angle x equals opposite value 1 divided by adjacent value 3. So whenever I'm looking for the angle, I proved to you how we could do tan to the inverse of 1. That's like dividing by tangent. So I'm going to do inverse tangent of 1/3 equals x. And we got 18 degrees. So x equals 18 degrees. Always circle your answer so you can see what the answer is. And we'll plug back in. This is 18 degrees. All right, let's try letter B. All right, starting from your x value, always starting from your angle, right? We're going to label. So what is 24? 24 is all the way across the triangle, so it's across the street. It's your across the street neighbor. It's your opposite value. 51, look at 51. It shares a side with x, but look at this. It's across from your right angle. I know that's confusing, but if it's across from your right angle, it's always your hypotenuse. Always, 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 okay? So we're dealing with opposite and hypotenuse. So I'm going to think so, ka, toa. What am I using? We're using sine, right? We're using so because we have opposite and hypotenuse. All right, so I know sine of the angle x equals opposite value 24 divided by hypotenuse value 51. So since we're looking for the angle, we're going to use inverse sine of the same ratio, 24 over 51 equals x. So let's plug this in. Inverse sine 24 divided by 51, and we get 28.07, rounded to the nearest degree, that's a 0, so it's going to stay 28. Plug it back in, 28 degrees. Circle it so I know it's the answer. All right, awesome. Let's do the next one. Y'all, this is it. I mean, there's no cross multiplying and dividing. That actually finding the sides is a lot harder than finding the angles. So this one is pretty easy. It doesn't get any easier or harder. It's about the same. Okay, always start from the angle. Remember, the hardest thing is deciding what to use, sine, cosine, tangent. Starting from the angle, let's decide. Well, we'll label 12, right? 12 is I share a side. So if I share a side, it's like sharing a fence. My next door neighbor is adjacent. 29 is also adjacent. However, because it's across from my right angle, it's hypotenuse all the time, right? So I'm looking for a trig function that is adjacent and hypotenuse. So what am I going to use? So ka or toa. Adjacent hypotenuse, I'm using cosine. So cosine, always of the angle, so x, equals my adjacent value 12 divided by my hypotenuse value 29. Since I'm looking for the value of the angle, I'm going to use my inverse cosine, times 12 of 12 over 29 equals x. You don't need the parentheses, but it will show up on your calculator. So let's plug that in, see what we get. Cosine 12 divided by 29, and I get 65.5. So I'm going to round to the nearest degree. Remember, nearest degree. So that 0.5 bumps my 65 up to a 66 degrees. Okay, so plug back in, 66 degrees for that angle. All of these make sense. Remember, we said you're going to find an angle between 0 and 90. So this makes sense, it's 18. This makes sense, it's 28. This makes sense, it's 66. We always want to think about reasonableness of our answers. All right, letter D, let's do this one together. Always start from your angle, remember? So I'm going to say, okay, all the way across the triangle. I have to travel across the triangle to get to my 28. It's my across the street neighbor or opposite. So we'll label. And then 47, I share a side with 47, but 47 is across that right angle. So it's always, always, always the hypotenuse, always the hypotenuse. All right, so I'm going to do opposite and hypotenuse. What am I going to use? So, ka, toa. Opposite, hypotenuse, I look for the first letters, O and H, it's sine. So we're going to do sine, always of the angle of x, equals opposite value 28. Divided by hypotenuse value 47. Since we're looking for the angle, we're going to use our inverse sine of 28 divided by 47 equals x. Plug it in our calculator. Inverse sine 28 divided by 47, 36.56. So we're going to look at that last number there, or that 10th number, to see what our degree. Since it's 5 or above, my 6 becomes a 7, and I have 37 degrees. Plug it back in, 37 degrees, and ask myself, does that make sense? Is it between 0 and 90? It sure is, so you're good to go. All right, there is a back. We're going to do these together in class, all right, because I want some of your input too. It looks like A is kind of funny. We do have it. These are like mixed questions, okay? So remember, always start from your angle. Go ahead and try these. B is a little funky because it's asking you for several different, we're going to be looking for several different things. So we're going to do these together, okay, in class, because this will be your assignment for today. All right. I'll see you in class. Remember, join us for the asynchronous part, and I'll see you soon.